Section 5.6, question number 3, second one. We need to graph the rational function. So the first step to find or to graph the rational functions is to find the vertical and horizontal asymptotes. So to find the vertical asymptote, I need to factor the denominator. X and x, I need two numbers. Their product is negative 12. Their sum is negative 1. That is negative 4 and positive 3. So vertical asymptotes, I will have x plus 3 equals 0. That will lead to x is equal to negative 3. And then x minus 4 equals 0. That will lead to x is equal to positive 4. And then the horizontal asymptotes, I know that the degree of the numerator is the same as the denominator. So y equals 2 over 1 leading coefficient over leading coefficient. That will give me y equals to 2. So the first step is to graph them. So I'm going to say negative 3, positive 4, and 2. Y is equal to 2. So this is x is equal to 4, x is equal to negative 3, and this is y equals to 2. Now I need to find x-intercepts and y-intercepts. So to find the x-intercepts, I will put the numerator equal to 0 and solve. So I have 2x squared minus 8 equals 0. I will add 8 to both sides of the equation. 2x squared equals 8. Divide by 2. I will get x squared is equal to 4. So take the square root, positive, negative. I will get x is equal to negative 2. X is equal to positive 2. So I will identify these. Positive 2 and negative 2 are the x-intercepts. I will find the y-intercept by putting x is equal to 0. So y equals 0 minus 8 over 0 minus 0 minus 12. So y equals negative 8 over negative 12, which is going to be y equals, reduce that, you will get 2 over 3. 2 over 3 is approximately here. So the first part of the graph is going to be this parabola here. Now, I would like to determine whether the other parts are here, or here and here, or one in the positive and one in the negative. The best way to do that is to use testing points, whether it's above the x-axis or below the x-axis. So I will use x and f of x. From the right one, I will choose 5 as my testing points. And then from this side, I will use negative 4 as a testing point. So now if you plug 5 in, you get 2 times 5 squared, which is 25, 50, minus 8 is 42 over 50, 25 minus 5 minus 12. So it's going to be positive. That's all I care about is the sign is positive. So that side is going to be above the x-axis, which goes between the asymptotes like that, approximately. And then if I choose negative 4, I will get 2 times 16 minus 8 is positive over 16 minus negative 4. That is 20 minus 12 is positive, so it is positive as well, which means the other part is going to be above the x-axis in between the two asymptotes like that. It is going very close, but it's not touching. So that is how we're going to sketch the graph. These don't have to be precise, by the way. And that is how you graph a rational function. Section 5.6, question number 5, and this is part D. We need to find the rational function. So to find the rational functions, we're going to identify the vertical asymptotes. We have x is equal to 2, and we have x is equal to -2. So the factors x minus 2 and x plus 2 are in the denominator. From the x-intercepts, we will find the factors in the numerator. So we have x is equal to -1, and the factor is going to be x plus 1 in the numerator. So we have the function f of x is equal to sum a times x plus 1, comes from the x-intercept over x minus 2 over x plus 2. This comes from the vertical asymptotes. In order to find a, we're going to use the y-intercept, which is this point, to find a. So when x is equal to 0, y is equal to -1/4. So 1/4 is equal to a times 0 plus 1 is 1 over 0 minus 2 is -2 times 0 plus 2 is 2. So we have -1/4 equals a over -4. We multiply both sides by -4. We get a is equal to, or -4. We get a is equal to 1. So the function is f of x is equal to x plus 1 over x minus 2 times x plus 2. Now into the behavior. The behavior, when x goes to positive infinity, notice how the graph approaches the 0, but it never touches the 0. When x goes to negative infinity, the graph again approaches 0, but it never touches 0. When the graph approaches the asymptote x is equal to 2 from the left, notice how the graph goes up, so increases without a bound. And then when we approach the asymptote x is equal to -2 from the right, the graph goes up, so it increases without a bound as well.